Our journey begins with a 1960 Valdivia earthquake in Chile, the most powerful earthquake ever recorded. How did it reshape the landscape and impact the lives of thousands? The 1960 Valdivia earthquake and tsunami, also known as the Great Chilean Earthquake, remains the most powerful earthquake ever recorded. With a magnitude estimated between 9.4 and 9.6, it struck southern Chile on May 22, 1960, and lasted for 10 minutes. The epicenter was near the town of Lumaco, but the city of Valdivia suffered the most severe destruction. Entire communities were shaken, rivers surged with debris, and the effects rippled far beyond Chile's borders. The earthquake triggered massive tsunamis that slammed the Chilean coast, with waves as high as 82 feet. These waves weren't confined to local shores. The tsunami sped across the Pacific Ocean, reaching as far as Hawaii, Japan, and the Philippines, where coastal areas were also devastated. In Hawaii's high-low, waves as tall as 35 feet caused widespread destruction. Despite the scale of the disaster, Chile's population density in the affected areas was relatively low, and building practices designed for seismic activity helped reduce casualties. The death toll still ranged from 1,000 to 6,000 lives lost. The earthquake reshaped the landscape in ways that are still visible today. In Valdivia, entire neighborhoods sank as the ground dropped, rivers overflowed, and wetlands were formed where land once stood. The city's infrastructure was decimated, leaving it without power or clean water, which created serious challenges for survivors. Landslides caused rivers to fill with sediment, and the rising waters destroyed homes and roads, leaving Valdivia in ruins. Despite heavy rain just the day before, a lack of drinkable water became one of the most urgent problems for the region's residents. The disaster didn't end with a quake and tsunami. 2 days later, a nearby volcanic vent, Cordon Col, erupted, likely set off by the massive seismic activity. With communication in the region cut off, other volcanic eruptions may have gone unrecorded. Next, we take you back to 2004, to the Indian Ocean. On December 26, 2004, the Earth's crust shifted in one of the most devastating geological events in recorded history. A colossal earthquake with an estimated magnitude of 9.2 and 9.3 megawatts struck just off the west coast of northern Sumatra, Indonesia. This was no ordinary quake. It was a megathrust event caused by the rupture along the fault line between the Indian Plate and the Burma Plate. Its force reached a Mercalli intensity of 9, enough to decimate infrastructure and reshape the land. The earthquake itself was unprecedented in many respects. It lasted over 10 minutes, the longest fault rupture ever observed, stretching about 720 to 780 miles. The power released caused the planet to vibrate by as much as 0.4 inches, and even triggered seismic activity as far away as Alaska. Ranking as the third most powerful earthquake ever recorded since modern seismography began in 1900, it stands as the most powerful earthquake of the 21st century and Asia's strongest in history. But the quake's terror did not end there. It unleashed a devastating tsunami, known as the Boxing Day tsunami, which sent waves as high as 100 feet, surging across the Indian Ocean. The tsunami swept over coastlines in 14 countries, causing destruction and claiming an estimated 227,898 lives. Coastal areas in Indonesia, Sri Lanka, India, and Thailand took the brunt of the impact, with Indonesia's Aceh province reporting the highest death toll. Entire towns were reduced to rubble, and countless families were torn apart. Beyond human loss, the tsunami caused severe environmental damage, destroying mangroves, coral reefs, forests, and wetlands. Coastal ecosystems were ravaged, leaving behind polluted waters and wrecked biodiversity. The cleanup and recovery of natural habitats required years of effort and billions of dollars in resources. Could we ever truly be ready for a disaster of this magnitude again? Onward to the 2011 Tohoku earthquake in Japan, which caused a devastating tsunami and nuclear disaster. How did it change our approach to disaster preparedness? On March 11, 2011, one of the most devastating natural disasters in history struck off the coast of Japan. The megawatt 9.0 to 9.1 earthquake, known in Japan as the Great East Japan Earthquake, originated in the Pacific Ocean, 72 kilometers east of the Ashika Peninsula, in the Tohoku region. Lasting approximately 6 minutes, it was the strongest earthquake ever recorded in Japan. The earthquake unleashed a catastrophic tsunami with waves towering up to 133 feet in Miyako, Iwate Prefecture, and traveling at 435 miles per hour in the Sendai area. These waves surged up to 6 miles inland, devastating everything in their path. Tragically, residents in Sendai only had minutes to react, and over 100 evacuation sites were wiped out. The freezing conditions, with temperatures at 32 degrees Fahrenheit in cities like Ishinamaki, severely hampered rescue efforts. By 2021, official reports tallied 19,759 deaths, 6,242 injuries, and 2,553 people still missing, with over 228,000 people displaced from their home as of 2015. The disaster's most far-reaching consequences was the Fukushima Daiichi nuclear crisis, where meltdowns occurred in 3 reactors. The loss of power prevented cooling systems from functioning, leading to overheating, hydrogen gas buildup, and explosions that released radioactive materials into the environment. Over 100,000 residents were evacuated from areas near the nuclear plants, many never able to return to their homes. Economically, the earthquake and tsunami inflicted unprecedented damage. Initial estimates of losses ranged from $14.5 billion to $34.6 billion, while total damages exceeded $300 billion, making it the costliest natural disaster in history. Even decades later, the earthquake's impact was deeply felt. On February 13, 2021, a magnitude of 7.1 to 7.3 earthquake struck off the coast of Sendai, causing additional damage in Miyagi and Fukushima prefectures. The aftershocks, which persisted for years, were linked to health declines across Japan, highlighting the long-term consequences of such a catastrophic event. Globally, the Fukushima Daiichi nuclear disaster prompted a re-evaluation of nuclear energy safety standards. Many countries reassessed their existing plants, with some, like Germany, deciding to phase out nuclear power entirely. Emergency response strategies were revised to emphasize redundancy in power supplies and cooling systems for critical facilities. Our next stop is the 1906 San Francisco earthquake, which nearly destroyed the city. What advancements in engineering and safety came from this tragedy? The San Francisco earthquake of April 18, 1906, stands as one of the most devastating natural disasters in U.S. history. With an estimated moment magnitude of 7.9 and a maximum Mercalli intensity of 11, the quake struck Northern Carolina. It caused catastrophic damage and altered the course of urban development in the region. The earthquake's force was felt over a vast area, from Eureka in the north to the Salinas Valley in the south, and as far inland as central Nevada. However, it was San Francisco that bore the brunt of the destruction. In addition to the violent shaking, fires broke out across the city, lasting for days and consuming more than 80% of its infrastructure. Over 3,000 lives were lost, and the disaster remains the deadliest earthquake in U.S. history and California's most lethal natural event. The earthquake occurred along the San Andreas Fault, a strike-slip fault that delineates the boundary between the Pacific and North American tectonic plates, stretching roughly 810 miles from the Salton Sea to Cape Mendocino. This fault is characterized by lateral motion, with the Pacific plate moving northward relative to the North American plate. The earthquake caused the fault to slip significantly, with displacements of up to 28 feet in some areas. This massive release of accumulated strain over a 280-mile segment of the fault caused widespread crustal deformation, as observed in post-event geodetic measurements. The epicenter, initially thought to be near Olema, was later placed offshore near San Francisco or possibly close to San Juan Bautista, based on modern analysis of triangulation data, eyewitness accounts, and tide gauge records of a small tsunami. The earthquake and subsequent fires devastated San Francisco's infrastructure, leaving tens of thousands homeless and transforming the cityscape. Reconstruction efforts reshaped urban planning, leading to stricter building codes and the widespread adoption of fire-resistant materials. The disaster also marked a turning point in seismology. The event spurred scientific inquiry into the mechanics of earthquakes, leading to the development of elastic rebound theory, which remains a cornerstone of earthquake science. Globally, the 1906 earthquake taught the people the importance of urban disaster preparedness and resilient infrastructure. The need for comprehensive risk assessment in seismically active regions was also proved to be paramount. Let's explore the devastating Lisbon earthquake next. The 1755 Lisbon earthquake, often called the Great Lisbon Earthquake, struck on November 1st, 1755, during the Feast of All Saints. This catastrophic event had far-reaching consequences, affecting not only Portugal and the Iberian Peninsula, but also parts of Northwest Africa. The earthquake, which had a magnitude of at least 7.7 on the moment magnitude scale, was centered in the Atlantic Ocean. Lisbon, already no stranger to earthquakes, had suffered similar tremors in 1321 and 1531. But the 1755 earthquake dwarfed previous events in terms of both magnitude and destruction. With Lisbon's population estimated at around 200,000, the earthquake claimed the lives of an estimated 30 to 40,000 people in the city alone, while an additional 10,000 may have perished in Morocco. The impact on Lisbon was devastating. Around 85% of the city's buildings were destroyed, including major landmarks like palaces, libraries, and religious institutions. The Royal Ribeira Palace, situated on the banks of Tagus River, was reduced to rubble. Historical records of Portugal's explorations by Vasco da Gama and other great navigators were lost to the flames, along with the royal archives, which housed centuries of important documents. The destruction of Henrique de Meneses' palace, home to a vast collection of 18,000 books, compounded the cultural loss, with entire collections of literature and history gone in an instant. Lisbon's churches, many of which were among the city's most significant landmarks, also suffered irreparable damage. Notable structures like the Lisbon Cathedral, St. Paul's Cathedral, São Vicente de Fora, and Santa Catarina were all badly damaged or destroyed. Even the Royal Hospital of All Saints, the largest public hospital in Lisbon at the time, was consumed by fire, tragically killing hundreds of patients who were unable to escape the flames. As the smoke of destruction cleared, the earthquake's effects rippled through political and philosophical circles across Europe. The disaster triggered intense debates on theodicy and the role of divine providence in natural disasters. The tragedy also marked a turning point in the study of earthquakes, as it became the first major earthquake to be studied scientifically for its effects over such a wide area. This laid the groundwork for the development of modern seismology and earthquake engineering. Next, we explore the 1976 Tangshan earthquake in China, one of the most deadliest in history. What were the human and economic impacts of this seismic event? The Tangshan earthquake of July 28, 1976, remains one of the deadliest and most destructive earthquakes in modern history. With a magnitude of 7.6 megawatts, it struck the industrial city of Tangshan in Hebei Province, China, and reached a maximum intensity of 11 on the Mercalli scale. Within minutes, 85% of Tangshan's buildings collapsed, and essential services were completely disrupted. Infrastructure, including bridges, roads, and communication lines, was also severely damaged, making rescue and recovery efforts nearly impossible in the immediate aftermath. The human toll of the disaster was unfathomable. The official death toll reported 242,769 fatalities in Tangshan alone, with 164,851 people seriously injured. However, accounting for missing persons, those who later succumbed to injuries, and the deaths in nearby cities like Beijing and Tianjin, estimates suggest that the total death toll surpassed 300,000. This makes the Tangshan earthquake the deadliest in recorded history, with a death toll that far exceeded other catastrophic earthquakes of its time. In the wake of the disaster, the lack of preparedness and insufficient infrastructure became evident. Tangshan, a busy industrial hub, was not equipped with the necessary defenses to withstand such a powerful earthquake. The city's buildings were not designed to be earthquake resistant, and the failure of critical infrastructure compounded the crisis. Rescue efforts were hindered by the collapse of bridges, leaving survivors stranded and without support. In the years following the earthquake, China invested heavily in improving its seismic monitoring, early warning systems, and public awareness campaigns to ensure that future disasters could be managed more effectively and that the loss of life could be minimized. Our next focus is the 1994 Northridge earthquake in California, which highlighted the need for improved building codes. What changes were implemented to enhance safety? The 1994 Northridge earthquake struck the Los Angeles area of California on January 17th, with a moment magnitude of 6.7. The earthquake's epicenter was located beneath the San Fernando Valley, approximately 19 miles northwest of downtown Los Angeles. It lasted for only 8 seconds, but achieved an intense peak ground acceleration of over 1.7 Gs, which made it one of the most powerful earthquakes ever recorded in the region. The earthquake was felt as far away as San Diego, Turlock, Las Vegas, Richfield, Phoenix, and Ensenada, with significant shaking across a wide area. Tragically, 57 people lost their lives, and over 9,000 people were injured, with the economic damages estimated between $13 to $50 billion, making it one of the costliest natural disasters in U.S. history. Geologically, the earthquake occurred along a previously undiscovered blind thrust fault beneath the San Fernando Valley. This involved a southwest dipping blind thrust fault, which ruptured upwards and northwestward. This fault, later named the Northridge Blind Thrust Fault or Pico Thrust Fault, is part of a larger system of faults that accommodate crustal compression along the San Andreas Fault. Notable damage occurred in several areas. The Northridge Meadows apartment complex collapsed, killing 16 people, and the Northridge Fashion Center in California State University. Northridge experienced extensive structural damage. Perhaps most notably, the Santa Monica Freeway, the busiest freeway in the US, suffered severe damage, causing traffic disruptions for months as repairs were made. Additional damage occurred in nearby areas, such as Anaheim, where a scoreboard at Anaheim Stadium collapsed onto spectators, injuring several people. Damage was especially severe in multi-story wood frame buildings, particularly those with parking structures on the first floor, which performed poorly during the earthquake. Numerous fires broke out due to ruptured gas lines, and water and gas lines were severed, leading to widespread issues with water pressure, affecting firefighting efforts. In the days following the quake, up to 60,000 residents in the affected areas remained without public water service. One of the more unusual effects of the earthquake was an outbreak of valley fever in Ventura County. This disease, caused by inhaling spores of a fungus, typically occurs in dry, dusty environments. The earthquake's landslides kicked up large clouds of dust, leading to a significant spike in cases, with 203 reported cases and 3 fatalities. Despite the devastation, the Northridge earthquake led to significant improvements in California's preparedness for future seismic events. Finally, we move to Haiti. On January 12, 2010, Haiti faced that horrifying reality. A catastrophic 7.0 magnitude earthquake struck near the town of Léogâne, not far from the capital, Port-au-Prince. In less than 30 seconds, life for millions of Haitians was irreversibly shattered. The tremors were relentless, the shaking reaching a Mercalli intensity of 9 in Port-au-Prince and its suburbs, strong enough to flatten buildings as if they were made of paper. Haiti's presidential palace, the National Assembly, the Port-au-Prince Cathedral, and even the headquarters of the United Nations Stabilization Mission all collapsed into rubble. The earthquake claimed countless lives, including Archbishop Joseph Serge Mio and UN Mission Chief Heidi Anabi. By February, the Haitian government reported a staggering death toll of 230,000. Later estimates ranged widely, with some reaching as high as 316,000, a number still hotly debated. Others believe the real toll was closer to 92,000, but regardless of the figures, the devastation was unimaginable. Over 3 million people were affected. Homes, schools, and businesses. About 250,000 residents and 30,000 commercial buildings were destroyed or rendered uninhabitable. Survivors, fearing aftershocks that continued to rattle the country for weeks, slept in the streets, in cars, or under flimsy makeshift shelters. The earthquake struck Haiti's most densely populated region, compounding the tragedy. The city's poor construction standards and lack of building codes meant that many structures were essentially death traps. Buildings were erected without proper foundations or steel supports, some clinging precariously to hillsides. It was a disaster waiting to happen. Haiti's vulnerability wasn't solely due to its geology. Decades of national debt, exploitative trade policies, and foreign intervention had left the country impoverished and ill-prepared for any disaster, let alone one of this magnitude. Many Haitians lived as squatters. And even before the quake, there were severe shortages of necessities like clean water and fuel. Geologically, the earthquake was a ticking time bomb. The Enriquillo Plantain Garden Fault System, which caused the quake, had been locked for 250 years, gathering stress along the boundary where the Caribbean tectonic plate grinds eastward against the North American plate. One can only hope for such disasters to never occur again. Which of these terrified you the most? Let us know in the comments section below. Hit that like button and subscribe for more engaging content from us. See you in the next one.